Ciao, I am. So, we're starting our third unit today, and we're going to move into something called quadratics. So today's notes 5.3, graphing, quadratics, and vertex form. So before we get into quadratics, I want to give a summary of what we've been learning. We've been learning everything linear so far. So linear equations, or what does linear mean? Linear means lines. So today we're going to talk about quadratics. So what does quadratics mean? So take a look, linear. Remember, linear means line. And usually when you graph it, you graph a line. The equation of a linear equation usually goes m equals, let's say, mx plus b, but the big component is that you're looking at the x with the degree of 1. All linear equations have a degree of 1. Degree of 1 means a line, and you have one solution. So that's linear. Now what happens in quadratic, we're going to up that, and we're going to have a degree of 2. So what does a degree of 2 do? Degree of 2 actually makes a shape that looks like this. This is called a parabola. It's more curved, and actually more degrees creates more curves. You're going to look at a parabola, and today we're going to learn how to graph this parabola. This parabola has two solutions because it's a second degree, has two solutions. And every chapter, every unit, we're learning a couple things. We're learning how to graph, we're learning how to solve. Graph and solve. So in this chapter, this unit, we're going to learn how to graph and solve only. And there's a lot of components to it, but basically that comes down to it. How do we graph? How do we solve a quadratic? So we can actually apply that to real life. And you're going to actually do a lot of real life stuff, and hopefully a lot more word problems than last unit. So let's take a look at a couple of parabolas. I created a presentation for you guys. So we're going to talk about parabolas today. Our goal is to how to graph a parabola by the end of today. So take a look. Before we get started, think about it. How does this relate? Why is this even important to us? How does it relate to the real world? Have you even seen parabolas out there in the real world? Think about it, that shape, parabolas. So I kind of showed you a couple pictures here. This is kind of where you might see parabolas. You might see it in juggling, throwing a ball, baseball. You know, you hit a ball up, it comes down. That makes the shape of parabola. Curves, ramps, water shooting up, shooting down, flashlights. All those are parabolic shapes. So that's actually really interesting, and you can do a lot of application with that, and we'll talk about that a little bit later. So basically, we're talking about parabolas, which look like this. I'm telling you a couple components of parabolas. These are very important. These right here are called the x-intercepts. These are also known as the roots, the zeros, and the solutions. These are the x-intercepts, the zeros, and the solutions. These are really, really important. When you're solving for a parabola or quadratic, you're actually finding where these are, the roots, the zeros, the x-intercepts, and the solutions. These are, imagine this, if you throw a ball up and it comes down, you're looking at where they cross the x-intercepts, where it lands. This right here is called the vertex. If the parabola is going upward, the vertex is a minimum value. Minimum means the lowest point on the graph. If the parabola is going down, the vertex is called a maximum value, the highest point on the graph. And these are the y-intercepts right here and down there somewhere. All right, very good. Also, parabolas have something called symmetry. They're symmetry. That means they're symmetric. That means if you fold it, the lines will fold right on top of each other. There's something called the line of symmetry. If I draw this line going straight down right here, and I fold the parabola along that line's not very straight, but if you can imagine, if I fold that parabola along that line, it will fold on itself. That's called the line of symmetry. This right here is called the line of symmetry, or also known as the axis of symmetry. Line or axis of symmetry. Very good. So let's continue on. Oh, I better erase all that stuff. So my question for you is, how do you graph a parabola? How do you graph a parabola? Actually, there's two forms you're going to learn, and I'm going to show you right now. There's two types of forms to learn when you're graphing a parabola. It's called standard form and vertex form. I don't know if you can see that. Graphing parabola, there's two types of form. We're going to learn one form today and another form tomorrow. So today we're going to learn about vertex form. And what is vertex form? It looks like this. Y equals a, parentheses, x minus h plus k. Then, tomorrow, you're going to learn about standard form. which looks like this: y equals ax plus bx, ax squared plus bx plus c. So today, all we're going to learn about is vertex form, and I'll do an example for you, and they'll do a couple more examples. So there's a couple components in here. First of all, a. What does a look like? Usually people see that and it kind of looks like a, kind of like y equals mx plus b, doesn't it? They see a and they think that's a slope. No, parabolas don't have slopes. Only lines have slopes. But you remember h and k, right? So what was h? H was the crazy horse. Remember that? H is the crazy horse, also known as the horizontal shift. Why does it crazy? Because it does the opposite. And k is the what? K is the kite. K is the kite. A kind of tells you, A is called the vertical stretch or shrink. There's an R in there. Alright, vertical stretch or shrink. Basically what it is makes the parabola actually skinnier or wider or fatter. It stretches it vertically. So if A is larger, it stretches larger vertically, making the parabola skinnier. If A is small, like 1/2, 1/4, it shrinks the vertically and makes the parabola fatter. Very good. So how do you graph a parabola? Usually if you don't know how to graph something, we actually have to make a t-table. So the beginning, this is how you graph a parabola. Take a look. I wrote some steps for you. First thing, you need to find the vertex. How do you find the vertex? The vertex, if you remember, is h, comma, k. After you find the vertex, you make a t-table. Then you plug in points and then graph the points. That's how you graph your parabola. So let's do this one at a time. Find the vertex. We look at here. We have to find h and k. Write down h equals, k equals. What's h in this case? It looks like over here, which is -1, but remember it's crazy horse, so it's +1. What's k in this case? Right here, this is my kite, that is -2, so my vertex is at 1, -2. Make a t-table. So I'm going to make a t-table here. And now I'm stuck. I go, which numbers do I choose? So this is where it gets a little confusing because I don't want to pick random numbers. Because if I pick random numbers, I might just, when I have my parabola, if I pick random numbers, I might just get this right here, and it looks similar to a line, which is no good. I want to have the whole parabola. So take a look. If I pick something starting on my vertex, right here, I could pick numbers around that, and it'll actually help design that shape of that parabola. So I really want to start on my vertex, which is 1, -2, and then pick numbers around there. What are numbers around 1? 1, next to it 0 and -1. The other way is 2 and 3. The more numbers you pick, the better it's going to look. I suggest you pick 5 numbers. All you got to do now is just plug it in. So let's plug it in. Plug in -1 in here. So take a look. I'll do it right over here. Y equals x, which is -1, -1 squared minus 2. Y equals -1 is -2 squared minus 2. Y equals 4 minus 2, which is 2. When I plug in my -1, I have a 2. Alright, how do you guys feel? Try to plug in the rest. I'll do one more for you. I'll plug in 0. Y equals 0 minus 1 squared minus 2. Y equals -1 squared minus 2. Y equals 1 minus 2 equals -1. Right here is -1. I want you to plug in 2. Pause and plug in 2 and 3 by yourself and see what you get. Good. Did you guys pause? I hope so. I did it in my head and I got -1 and 2. I want you to look at that carefully. Do you notice anything special about that? I noticed, like, look at the numbers. They kind of repeat over here. I wonder why is that. Remember, a parabola is symmetric. Remember this line of symmetry? When you pick a point over here, isn't that the same y value over here? If I pick a point over here, isn't that the same y value over here? So, because it's symmetric, these values will be the same as that value. So are you going to cheat yourself and just plug in 2 numbers and then rewrite those numbers? No. I suggest you plug in all 5 numbers or 4 numbers and then check if it actually comes out to be correct. So if you notice they're not symmetric, maybe you did something wrong. So use it as a way to check your work, but not to cheat and not do less work. let's graph it real fast. I don't have a graph here, so I have to make my own graph. This is my x, this is my y. Let's graph this. I have to have negative 1, 2, negative 1, 1, 2 right there. 0, negative 1, 0, negative 1 right here. 1, negative 2 right here. 2, negative 1, and 3, 2. Look at that. Does that look like a parabola to you? Let me make it a different color so you can see a little bit better. Does that look like a parabola to you? It kind of does, and it goes up. So take a look, graph your parabola going up, draw down, curve it. Do not make a V. It's not a V. It is a parabola. Curve it up and go back up. How do you guys feel? And that's how you graph a parabola. We're going to talk about components a little bit later. Will the parabola go down? What will make the parabola go down? Any other questions? Alright, I think that's all the time we have. We're going to do one example and then we'll come in class and practice this some more. We'll actually do one before we get started tomorrow. Alright, have a good day. I'll see you tomorrow. Bye.